Good afternoon. This is Professor Michael Bailey at Dallas College, and we are starting Chapter 5 with Section 5.1 of Fundamental Identities in our Trigonometry class. We're going to learn some fundamental identities. Most of these will actually be review, and then we're going to use some of the fundamental identities, and we're going to kind of learn a basic practice that we'll use throughout this chapter. This is one of the more difficult sections of the course, working with identities, memorizing the identities, and then working with them. So the first identities that we look at are the reciprocal identities. These are not new to us. We know that cotangent and tangent are reciprocal, secant and cosine, and cosecant and sine. So again, this is just a review of these identities. I like the way that they've put these here because they help us remember how to use our calculator to find cotangent, secant, and cosecant. Okay, so memorizing these identities can make your calculator much more useful, specifically in this form. Remember the quotient identities, specifically that tangent equals sine over cosine, and cotangent, of course, is the reciprocal, which is cosine over sine. Tangent is sine over cosine, and cotangent is cosine over sine. Again, these are not new, but review of some identities we've seen previously. We've also seen the Pythagorean identity, specifically the main one, sine squared plus cosine squared equals 1. And then the other two are derivations of this by dividing each term by either sine squared or cosine squared. And we get tangent squared plus 1 equals secant squared, and 1 plus cotangent squared equals cosecant squared. And I just dropped this in here so you can see. Notice the numerator here in what you see in yellow is sine squared plus cosine squared equals 1. If we divide each term by sine squared, then notice here we get 1. Cosine over sine is cotangent, so since they're both squared, we get cotangent squared. And 1 over sine squared, this is the reciprocal of sine, which is, of course, cosecant. So just wanted to show you how these other two are derived. The tangent squared plus 1 identity is if we divided each of these by cosine squared. Notice then we'd have sine over cosine, which is tangent, cosine over cosine, which is 1, and 1 over cosine, which is secant squared. So I just wanted you to see that if you know the basic identity, sine squared plus cosine squared equals 1, that you can derive these other two identities versus memorizing them. Even and odd identities, this is really about looking at positive and negative angles. And while these angles don't look like they're exactly the same, imagine that they were, and this will help us kind of understand the odd and even identities. So notice if these were the same, that functions that are x value functions, for example, cosine, the cosine of an angle is equal to the cosine of the negative angle, because notice cosine is the x value. Cosine is the x value, which doesn't change here. And even if it was in the second and third quadrant, again, the x would not change. The y does change. So notice that if this was a sine, the sine of the positive angle would equal the negative sine of the negative angle. And so that's how these identities are created. You can, again, pretty straightforwardly see sine and cosine when you're thinking in terms of x and y, which means that also handles cosecant and secant, the reciprocals. The tangent and the cotangent are a little more complicated because remember, based on the quotient identities, tangent equals sine over cosine, so there's a little more involved here. So if you understand the graph, you can quickly interpret the first 4 even-odd identities by thinking about what a positive angle and a negative angle of the same measure is. and see that the x values would be the same, the y values would be opposite polarity. For tangent, you might just want to remember this. So tangent follows along with the sine, okay? Tangent and cotangent follow along with sine. In trig identities, theta can be an angle in degrees. It could actually be a real number, or it could be a variable, okay? So we don't really know, and it can represent any of those, okay? So let's look at how we use these identities to find some different function values, okay? So we're going to find a trig function value given one value and the quadrant, all right? So we're given that tangent theta equals -5/3, and we're given that we're in quadrant 2. Find each functional value, and there's more than this one question here. The first thing we have to do is find the value of secant. So what we're going to do is we're going to look for an identity that just has tangent, what we're given, and secant, what we're looking for. Well, one of the Pythagorean identities has this, okay? We can then use this, plug in the values, and then solve for secant. So tangent equals -5/3, so we're going to square that, add 1 to it, and we get secant squared. When we do this, we get secant squared equals 34/9, so we take the square root of both sides. Now remember that when we take the square root of a squared term, we have to consider the positive and the negative. In quadrant 2, secant, which is the reciprocal of cosine, in quadrant 2, cosine, or the x values, are negative, so secant would be negative, so we pick the negative square root. Again, this could be plus or minus the square root of 34/9. Since we're in quadrant 2, secant is negative in quadrant 2 because it's related to the x value or the cosine function. Okay? Sine. So now we're using that same value of tangent given to us, but now we have not only the value for tangent, we also have the value for secant. And of course, if we have the value for secant, this also gives us the value for cosine. It's reciprocal. So now we're going to ask what identity uses tangent and sine and either secant or cosine. Well, tangent is equal to the value of sine over cosine. And so we do have the cosine value, which is the reciprocal of secant, so we can plug those values in. Here we've done some algebra ahead of time. Sine equals cosine theta times tangent theta. And of course, cosine is 1 over secant. So we can now actually plug in the actual values that we had found in the last example and the given. Okay? So here we get that sine theta equals, it looks like it's multiplied, but it's not, it's an equal there. Sine theta equals 5 times the square root of 34 over 34 when we rationalize the denominator. So this looks like it would be pretty simple, right? Because we're looking for the cotangent and we were given the tangent. But notice that the angle is negative. And this is when those negative angle identities become important. So again, we can figure out the sine and the cosine pretty easy, thinking in terms of x and y values by quadrant. And then the tangent, I said, follows along with sine. So that's kind of mirroring the y value. In what we get here is that the tangent of negative x equals the negative tangent of x. All right, so we can use this identity. So the cotangent of negative theta equals negative cotangent of theta, of the positive angle. But first, let's slow down there. I'm trying to do too much in my head, and that often gets us confused. So first of all, we know that the cotangent of negative theta equals 1 over the tangent of negative theta. And we don't have this value, we have the tangent of positive theta. So we're going to use this identity to convert this to the negative tangent of theta. And now we can plug in that value that was given to us in the original problem, the tangent of theta, and simply solve this problem. The tangent of theta was equal to negative 5/3. We apply a negative to that, and it's 1 over that value, or the reciprocal. So we have 1 over 5/3, positive 5/3, and of course the reciprocal of 5/3 is 3/5. All right. So again, a couple things here. Looking at what you're being given and what's given in the problem and what you're searching for, then thinking about how they're related with identities, trying to limit the identity that only has those two values or two functions, and then playing around with them algebraically, etc. Remember that you always have to figure out which quadrant you're in and base the functional value on that quadrant. Especially if you're taking a square root plus or minus, you may forget that, but we're always going to be using the quadrant to figure out what the functional value is for that quadrant. Write cosine in terms of tangent x. Okay, this is an interesting problem. So again, we're going to try to find a identity with just tangent and cosine. But we can also think in terms of secant, which is the reciprocal of cosine. Because if we have the secant, we have the cosine. Well, of course, we know that we have the Pythagorean identity, 1 plus tangent squared equals secant squared, which is also related to, again, secant is simply 1 over cosine. So notice if we reciprocate this entire equation, 1 plus tangent squared equals secant squared, we already have cosine squared on the right side of the equation. And so now we have cosine squared defined in terms of tangent squared. So we can easily find cosine in terms of tangent by simply taking the square root of both sides. Okay, if we do this, we get plus or minus the square root of 1 over 1 plus tangent squared x. Of course, if we take the square root of the numerator and the square root of the denominator, we get what you see here, plus or minus 1 over 1, the square root of 1 plus tangent squared x. And then, of course, we rationalize square roots so that they're not in the denominator, and this is our final answer, noting that we do leave the plus or minus there because the sign is going to depend upon what quadrant x is in. So we get cosine x equals plus or minus 1 plus the square root of, the square root of 1 plus tangent squared x over 1 plus tangent squared x. All right. Again, what we're doing here is looking at the two functions, trying to find an identity that has just those values or is a reciprocal value because those are easier to plug in. Okay. This is an example I want you to pay close attention to because when we're talking about proving identities, this is one of the most common practices we will do. Specifically, we will rewrite an expression in terms of sine and cosine and then simplify. Okay, so this is giving you a little taste of what's to come about how do we prove an identity. This isn't an identity, this just is a rewrite of an expression, basically one side of an identity. So it says to first rewrite these in terms of sine and cosine and then simplify. Well, cotangent equals cosine over sine, and cosecant equals 1 over sine. So let's first substitute those in. Cotangent equals cosine over sine, but since it's cotangent squared, we're going to square both the numerator and denominator. Cosecant is 1 over sine. Of course, 1 squared is 1, and so we get 1 over sine squared. Okay? So now we're just dealing with this expression on the right side of the equal, and we want to simplify it. Well, we have a fraction in the numerator and a fraction in the denominator, and when we have these complex fractions, we want to eliminate a complex fraction by multiplying both the numerator and the denominator by a common denominator. Luckily, here we have a common denominator, which is sine squared. So all we have to do is multiply the numerator by sine squared and the denominator by sine squared, and this is going to clean this up quite a bit. Okay. Notice we can do this because what we're effectively multiplying by is 1. Sine squared divided by sine squared is 1, and anything times 1 does not change the value. When we multiply this through, we get sine squared times 1, which is sine squared, plus, notice the sine squareds here will cancel out. So we're just going to get sine squared plus cosine squared in the numerator. And here we get sine squared minus sine squareds are going to cancel out, and we get 1. So we get sine squared minus 1 in the denominator, as you can see here. Let's move this to the top of our scratch paper so we can continue on. Hopefully you immediately recognize the numerator is an identity that we know, specifically the Pythagorean identity. Sine squared plus cosine squared equals 1. The denominator is a little more confusing. It's got sine squared and 1 in it, but we have to be careful because sometimes we make mistakes if we don't do our math and do it on paper, etc., to make sure that we've done it right. So notice if we have the first identity here in bold in the yellow, sine squared plus cosine squared equals 1. If we subtract 1 from both sides, notice on the left we do have sine squared minus 1. And so we just need to get rid of the cosine squared by subtracting it from both sides. And thus we can see that sine squared minus 1 does indeed equal negative cosine squared. Okay? So we have 1 over negative cosine squared by substituting in 1 from the Pythagorean identity for sine squared plus cosine squared, and substituting in negative cosine squared for sine squared minus 1. Of course, this isn't in its simplest form because 1 over cosine squared is secant squared. And so we can see that this more complicated formula, 1 plus cotangent squared over 1 minus cosecant squared, is actually equal to simply negative secant squared. Okay? So this is a very typical thing that we might do when we're trying to simplify identities, is to replace all the other trig functions or rewrite them in terms of sine and cosine, and then simplify it. Okay. This is something I'm guilty of a lot, and I guess it's because I'm lazy. But this is saying that you should never write just sine squared plus cosine squared equals 1. You've heard me say that multiple times in this lecture alone. You